So I briefly said here that the CO2 and methane signatures are also there in the medieval warming and the Little Ice Age, but obviously it got completely dominated by the industrial period warming and CO2 and methane emissions. There are more detailed records which show it more clearly. I won't go into it, but just remember that these ice albedo feedbacks work at all time scales, and the trigger need not be just orbital forcing. It can be the other solar forcing, which is obviously related to sunspots, right? Remember the idea of the sunspots? We said there is a 11-year cycle, so there are decadal sunspot cycles that we can see, and just focusing on this medieval warming and coming out into the Little Ice Age, it can be done by combining volcanoes, increased activity during the 12th century, followed by the series of so-called sunspot minima, which were recorded by the Chinese and over Taiwan and some other countries, India, Arabs, and so on and so forth. Okay, so this is showing the relative glacier extent on the right side and decadal sunspots on the left axis, abscissa. What is the ordinate and what is the abscissa? I forgot. Anyway, on the horizontal axis we have years. So we're going from the 1000-year AD to just after 2000. The main thing to remember, of course, again, is that sunspot minima corresponds to a radiation maxima. Radiation minimum as well. Remember, don't make the mistake I just made. When sunspots increase, the radiation output also increases because the magnetic storms make a dark spot, but the radiation around them, the faculae, actually emit more radiation. So sunspot minima is a radiation minimum as well. So you can see that the glacier extent here, you have to be careful, the axis is reversed, so the glacier extent is maximum when the red line is at the bottom, and when red line here is at the top, it is minimum. So just to show the correspondence between sunspots and the ice extent, the axis has been flipped on the right hand side. So as sunspots decrease and radiation decreases, remember, ice extent, glacier extent increases. Okay, so probably the volcanic activity triggered the end of the medieval warm period and started to regrow the glacier on Greenland, for example, and made it difficult for the Vikings to continue to live there, so they went extinct. And the end of the medieval warming was then driven into the Little Ice Age by these continued sunspot activity, multiple minima, the Oort, Wolf, Sporer, Maunder, Dalton, and so on. So there are multiple decades of minimum solar activity, so reduced radiation from the sun, which continue to produce this kind of, so you can see that the maximum glacier extent is here, and then it slowly increases over time as the sunspot minima continue to provide a forcing to the ice albedo feedback. Here we are again with the ice albedo feedback, right? So even on these multi-century time scales, ice albedo feedback worked very well. This is just showing the same thing combined with the flux data. Solar flux is shown here. You can see that this is just a couple of watts per meter squared. Okay, and the temperature is now coming out of the Little Ice Age. We don't know whether the Little Ice Age ended because of solar activity. You can see that the solar activity doesn't seem to be that different into the 20th century, and the flux forcing is not that different. we even had a minimum in solar activity in the last couple of decades. The temperature continues to warm. So the Little Ice Age could have ended because of the beginning of the industrial activity. There is additional detail there. Coal burning produces lots of black carbon particles, and it is now known that when you put black carbon into the snow, snow melts faster. Why? Because black carbon absorbs. It's low albedo, so it absorbs shortwave and accelerates snow melting. So it's possible that beginning of the Industrial Revolution began to put a lot of soot particles onto the glaciers that existed in Europe, for example, and began to accelerate the melt, and that's how we came out of the Little Ice Age, and then CO2 emissions, methane and nitrous oxide took over and have been responsible for the more recent warming. You can see the complications of interpreting past records without having all the details, but now the solar heliophysics modeling is greatly improved, so we can reconstruct the changes in radiative forcing. We can combine with the data that exists for other things like the Argentieri Glacier in France and so on, and the accelerated retreat of glaciers over the Alps, some parts of Himalayas. Himalaya is also complicated like Antarctica because it's having some parts where glaciers are growing or not retreating, but there are some parts where the glaciers are retreating. So the mountains make for very complicated flow patterns. And remember, Himalayas are in the subtropics, so pretty warm. Monsoonal circulation brings lots of humidity, and during the winter there are so-called western disturbances which bring snowfall all the way from the Mediterranean and so on. So Himalayas is quite complicated, but Alps are almost uniformly having retreating glaciers. Antarctica is complicated, Greenland is retreating, and so on. You have to carry so many concepts in your head, but always carry the concepts and be able to add them, to synthesize, to produce knowledge and understanding from the pieces of information you are collecting along the way.